to Projects. In this video, I will be explaining about noise reduction in web data, a learning approach based on dynamic user interest. Introduction. Users rely on websites to obtain numerous forms of information such as news, sports, technology, and more in today's digital age. However, web pages frequently contain noisy data such as photos, video clips, or adverts, making it difficult for consumers to obtain the information they need. Traditional noise reduction approaches employ static web matching patterns in which the appearance and feel of main page are compared to rest of the material and unmatched data is deleted to present only the essential information. This static strategy, however, fails when web pages change dynamically. So to overcome this issue, noise web data learning, which is NWDL technique, is proposed. Objective. The project goal is to create and implement the noise web data learning, which is NWDL technique, which analyzes user access patterns and time spent on pages to dynamically identify user interested web pages. The purpose is to overcome the limits of static noise reduction techniques and provide a quick way to improve and remove irrelevant stuff from web pages. NWDL attempts to improve user experience by offering more relevant information and enhancing overall usability of web pages, resulting in a more gratifying and personalized web browsing experience for users. These are the requirements for the project. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required. In software requirements, Python IDEL of 3.7 version is required. These are the algorithms used in the project. First one is noise web data learning. The primary algorithm is used which dynamically identifies user interested web pages by analyzing user access patterns and time spent on pages. NWDL uses a combination of frequency based analysis and time duration between page visits to distinguish between interested and noise pages. Second one is support vector machine. An existing machine learning algorithm used for classification tasks, SVM is often employed in web data analysis to classify pages into different categories, including interested and noise pages in this content. Naive Bayes algorithm. Another classification algorithm commonly used in text and web data analysis, Naive Bayes is known for its simplicity and effectiveness in categorizing data. Fourth one is random forest, an ensembling learning method that uses multiple decision trees to classify data. Random forest is used for its ability to handle complex data and improve accuracy. Fifth one is k-nearest neighbors, which is KNN. It is a non-parametric algorithm used for classification tasks based on the similarity of data points. KNN identifies the class of a data point based on the classes of its neighboring data points. Methodology. These are the design modules for execution. First one is to upload weblog dataset. In this module, we will be uploading weblog dataset to the system. Next one is to calculate depth user visit. In this, the system processes the data to calculate the depth of the user visits. Next one is to view user interest pages. Once the depth of the user visit is calculated, this module allows the user to view the pages that are identified as the user interested pages. Next one is to view confusion matrix. In this module, the system evaluates the performance of the noise web data learning technique and compares it with the other existing algorithms which are SVM, Naive Bayes, random forest and KNN. The confusion matrix is a performance evaluation tool that provides information about accuracy of the prediction results. Next one is dynamic interest category graph. In this module, it presents a graphical representation of the web page categories and their frequencies of access. Each module plays a crucial role in noise reduction in web data project, contributing to overall goal of dynamically identifying and recommending user interested pages while reducing noise in web data. For execution, first open the code folder. This is the code folder and this is the dataset file and this is the weblog dataset. Here we have server IP, user ID, access page, date, time, URL, and these are the parameters for the project. And this is the main code file and this is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file for execution. So double click on it for execution. This is the graphical user interface of the project. With this, we can interact with the program, and this is created by using Tkinter library in the Python. So first click on the button Upload Weblog dataset. Select the Weblog dataset, click on Open. Here, dataset is loaded. Now click on the button Calculate Depth User Visit to calculate frequency and weight of each page visit by single users. Here, we can see total frequency of the users, which is 203. Now, to see the frequency of each access page, we need to see the console. So, I will be opening the console. Here, we can see user ID, frequency of each page accessed by them. So, to see page name and weight, I have to copy the user ID details. So, I will be copying, and here, I need to click on the button View User Interest Page. Here I will be copying the same ID and click on Open. Here I can see the web page name and the URLs. Now click on the button View Confusion Matrix. Here we can see noise and interested pages for each particular algorithm. For naive Bayes, it has shown interest and noise. For SVM also it has shown. For random forest algorithm also it has shown here interest and noise. For k-nearest neighbor also it has shown. Here is for NWDL algorithm. Now click on the button Dynamic Interest Category Graph. Here on x-axis it represents the category, and on y-axis it represents the total count of those categories. Here we have home, news and technology. Close this graph. Now click on the button Open Interest Page to see the web page. So for this, first we need to click View User Interest Page again. So here I will be copying the ID and click on OK. Here I will be selecting the link, copy it and click on Open Interest Page. Here I will be opening it and click on OK. Here it has taken to the page, web page. So close this web page, close this GUI. Conclusion: NWDL dynamically discovers user-interested pages and effectively removes extraneous information by monitoring user access patterns and time spent out pages. NWDL surpasses standard algorithms such as SVM, naive-Bayes, random forest, and KNN in predicting user-interested pages with the high accuracy. According to the experimental data, this method dramatically improves the user experience by giving more relevant information and personalization when exploring the web. NWDL is a potential method for noise reduction in web data due to its ability to react dynamic web page changes.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.